Hello, everybody, one and all. Welcome to this episode of Informal IT. This is going to be a little bit more like a podcast than an actual video, and I apologize that I don't have anything really cool to look at other than maybe my backsplash here. The topic for today is the AI technology rabbit hole. I'm titling it that because, you know, I asked a couple of questions, I looked them up, that led to more questions that kept me going. And if I didn't stop, I'd probably still be going. That's a beautiful thing about a text file. If it's digital, you can keep writing and writing and writing until your computer's memory runs out. Thankfully, it's not that long. But well, first, let me just bring up a browser here. The first thing that was thinking along lines were GPU bootcamp, or at least I'm calling it that because it started with me hearing two things on the topic of Nvidia: Hopper and Blackwell. I've heard of Blackwell being a GPU, so I'm assuming Hopper was that. So I looked it up. The basic question: what is Hopper and Blackwell? And Hopper and Blackwell refer to two generations of Nvidia GPU architectures. Blackwell being the newer one, more powerful architecture designed for AI and data-intensive workloads, while Hopper was its predecessor. Now, if you want a more detailed breakdown, the Hopper architecture, its purpose was designed to accelerate AI and machine learning workloads, particularly focusing on large language models and, for generative AI. Key features being it introduced the transformer engine, software to facilitate quantization of higher precision models. That's part of the reading. It's like sometimes if I'm really tired, I'm gonna mispronounce a lot of things. Please excuse that. Well, anyway, like I said, software to facilitate quantization of higher precision models to lower precision, for which Hopper has greater throughput. Great. And this includes the H100 GPU. I guess the H is for Hopper, a high performance GPU for AI and accelerated computing. And that set a new standard for AI and accelerated computing back in 2022. Now, if we move on to its successor, Blackwell, that architecture, its purpose designed to build upon the Hopper architecture by offering even greater performance and efficiency for AI and data intensive workloads. I just love that phrase, data intensive workloads. Needless to say, data scientists, analysts, that sort of stuff, number crunching, beautiful. Now, if we look at those key features, we are going to be jumping into the second generation transformer engine with the support of the new Open Compute Project. We can call it OCP. That's community driven or defined micro-scaling formats. I believe they call them the MXFP6 and MXFP4. I don't know why they're going with the lower number after the fact, but hey. Now, if I actually want to slow down here, if I look at the Hopper GPU image, we can get a better look at what it's going to look like. Let's go to images here. This is it. It's the Hopper. Ain't it pretty? See if I can get a bigger image here. Come on, show me. There it is. I remember the very first time. Do I really want to agree? Maybe I do, maybe I don't. I don't really have that kind of time, do I? Anyway, I remember the first time I saw this image, I thought this was effing cool. But I really wasn't thinking about what it was for. I'm like thinking, okay, awesome gaming. And that just goes to show you how old I am. or maybe not. But anyway, this is what it looks like, so that way you have a good idea what we were dealing with. Now, if we also want to go and look for the Blackwell GPU image, this is what it looks like, and this looks really cool too. Let's see if we can get something here. It's really awesome. And there he is. Nope, there it is. Look at that. If we thought Hopper looked really awesome, it looked like basically a graphics card with a fat GPU right in there. Then you look at this. Everything that was there is now in here, and there's more to it. Really awesome. And I like this graphic because it also gives you a little information about the CUDA GPU, speeds, all that. Fantastic. Now, back to where I was at before. Key features on the Blackwell. We already talked about the transformer engine, the Open Compute project, and microscaling formats. Uh, the GPUs, the B200, B for Blackwell, of course, a key successor to the HGX H200, or should I say the H208 GPU if I want to be specific. But to be honest with you, I don't have that much information on all the stuff that goes in between. Let's just agree that we're doing a lot of hopscotch or leapfrogging from one point to the other, and we're gonna like gloss over the stuff in between. And if anybody really feels that they need to know, they at least have a basis to start looking in that direction and look things up for themselves. Now, other features. It delivers 2.5 times the performance boost over the previous generation architecture. And that includes Nvidia's confidential computing, which projects sensitive data and AI models from unauthorized access with strong hardware-based security. Now that is a beautiful thing and something that a lot of people don't take into consideration, and they should. If you're really into cybersecurity, you don't really hear too much about hardware-based security going this deep. So we're not just worrying about just okay locking down the computer or locking down the BIOS. We're actually locking down the GPU. Considering we're talking about artificial intelligence being one of the key milestones here, it's a good idea to lock that thing down. Now, what else do we have here? Blackwell performs the platform comprises over 208 billion transistors manufactured using custom-built Taiwan semiconductor process with a 2 reticle limit on the GPU dies. Now, I'm reading this and I'm seeing it kind of explains it right here also. So there's a 10 terabyte per second chip to chip link. So if you're linking these puppies together, oh my goodness. Now, remember I mentioned that this is a rabbit hole. I mentioned something called a transformer engine. What the hell is it? Apparently, it's a library for accelerating transformer models on GPUs, specifically Nvidia GPUs. And that will provide better performance with lower memory utilization in both training and inference. Now, what is meant by training and inference, you may ask? Especially with relation to artificial intelligence, well, the training refers to the process of feeding an AI model with data to learn patterns and make predictions. Now, if we want to know more about AI model training, this phase involves the providing an AI model with a curated data set to learn from. The goal is to enable and model and recognize patterns. The relationships within that data is allowing it to make accurate predictions and decisions. Now, for those of you that have heard about DeepSeek, yes, they're using what they call lower quality processors, but the techniques to link them together are basically trying to get to the same place. Eventually, we will dive in that direction. But I'm still on the Nvidia bandwagon here, trying to figure out and learn as much as I can, because I have an idea, but I'm looking for clarification. And as I'm looking this stuff up, I'm saying it out loud. Hopefully, it's actually helpful for anybody else that's asking these questions and had nobody to answer them and don't have the time to look it up. So, now that we skip past that point, what's inference? And that's when the trained model uses those learned patterns to make predictions on new and unseen data. Now, the AI model for inference. Once a model is trained, it enters the inference phase, where it is deployed to make predictions or decisions on new data that hasn't had any previous input or data sets to work with on. Now, the inference involves the model applying its learned patterns to the new data to generate outputs and predictions, or predictions, and or. You get the idea. This stage is crucial for the practical application of AI models, and it's determined, or should I say, it determines how well a model can perform in a real world scenario. Model optimization during the inference phase, it focuses on improving the usefulness of the model while lowering the cost and minimizing latency. Now, that is one hell of a mouthful to take in. And you mentally could just take a break right there. And trust me, I did for a little bit, but then I kept asking more questions. Like the Open Compute project. Compute, whatever. The OCP is a community that designs and shares hardware for data centers. Its goal is basically to create more efficient, effective, and scalable computing technology. How it works, it encourages companies to share their hardware designs. It promotes collaboration and transparency of hardware design. And it helps standardize server hardware for workloads like artificial intelligence and encourages modular approach to data center infrastructure. We can understand that this is pretty much not necessarily a non-profit consortium, but it's all the big boys and all the other people that are in the weeds trying to get on the same page so that way everybody's technology can actually work well together. Otherwise, you get these garage mad scientists, a little like me, that will dumpster dive and buy the newest piece of technology and solder things together to try to see if we can get them to work. Okay, maybe I haven't created that kind of a fire hazard yet, and maybe we never will. But let's look into the benefits. The OCP can help reduce hardware complexity and cost. Beautiful. It helps improve performance and sustainability. We can all get behind that. It helps reduce the total cost of ownership for the data centers. That actually might lead into lower tier players trying to get into the industry to build their own. That is also a good thing. It also helps reduce the procurement time and research efforts and expenses. All good things. Now, from there, we might want to go a little further into other things. Let's see. As far as the history of the OCP, Facebook, which is now Meta, launched the OCP back in 2011, and it significantly influenced the design and operation of large-scale computing all over the world. Many companies are members of the OCP now. That includes ARM. I like their processors, especially on that Raspberry Pi. Meta, of course. IBM's in here. Intel's here. Google's here. Microsoft. And also Dell. It's only a matter of time before Apple gets in on it if they haven't already had some say somewhere along the way. But now we're going to sidestep and look into something else. Nvidia's confidential computing and hardware-based security. Now, this feature is integrated into the GPUs, like Hopper and the Blackwell series. That protects sensitive data, the AI models, and the applications while they're actively being used by creating a secure, isolated environment where only authorized entities can access and modify the information. Essentially, safeguarding the data in use through trusted execution of the environment. Now, on the hardware level itself, this means even if the operating system or hypervisor is compromised, the data within that environment remains protected. Key points about the confidential computing is hardware-based isolation. Unlike software-based security measures, this leverages dedicated hardware components on the GPU to create a physically isolated environment for data processing, preventing unauthorized access of the host. Now, when they say trusted executing environment or T, this secure area within the GPU is where the sensitive data is processed, ensuring only authorized code can access and manipulate it. Now, if we're going to talk about data protection and use, the primary benefit is that it protects the data while it's actively being used in the computations, not just when it's stored. And that's seriously addressing a critical security gap. Now, applications in sensitive industries, this technology is particularly valuable for sectors like healthcare, finance, and government. But honestly, I thought that goes without saying, but it's been said. And okay, now what's the impact? Nvidia aims to actually minimize performance overhead, and that'll also leverage the security features without sacrificing performance. Now, this is one of those segments where, okay, that's interesting, and if I wasn't so damn tired, I'd actually look a little further into it. But what I did find out when I was actually looking this stuff up was on the topic of encryption of how it works. Data is loaded into the environment or the trusted execution environment, and it's encrypted using keys that are only accessible within that environment that's isolated. Now, as far as that station, we're talking about a mechanism to verify the integrity of the compute environment before processing sensitive data, ensuring that the system is running the way it's supposed to, as expected. Now, we also want to take a look at the secure communication. The data transfer between the host system and that environment, the T, is encrypted to prevent any eavesdropping. So, we're talking about avoiding a man in the middle attack, but this is going really deep as far as that kind of behavior. Now, what are the benefits of the NVIDIA confidential computing? You got enhanced data privacy. Okay, you got compliance with regulations. This enables you to meet the stringent data privacy requirements. Uh, if you're in the EU, the GDPR, you definitely, if you're aware of that, you are definitely trying to make sure that no one's data gets compromised, and that's part of what this is about here. Uh, the US has its own version, and quite honestly, I can't remember what it is. I'll look it up later. I'm not sure if I'm going to actually make another podcast just to talk about it, but I will look it up. Now, we also have improved security for AI workloads. This is basically to protect the model itself and also the data during the training and the inference phases. And probably the best benefit of all, reduced attack surface. If anybody's taking the Security Plus, the topic of an attack surface is definitely something you're familiar with. And this is to address that, or should I say, part of the technology that's going into these GPUs. Okay, I think I'm running out of steam. But Like I said, this is a rabbit hole, and I might actually go a little further, but I think I've talked long enough. For anybody who's been this patient, thank you, and have a good evening.